This video is on the objective use the sum and difference formulas to simplify trigonometric expressions. And this is number 1, so the first video on a question related to this objective from your Newton Alta homework. And before I get into that, well, let me just show you the question. And again, if you want to see some more stuff, click on More Instruction and look at their videos, their notes, their examples. Hopefully those help you out. So what we're asked to do here is, considering only the values of alpha and beta, for which the cosine of alpha minus beta, the cosine of a difference of two angles, divided by the sine of alpha times the sine of beta is defined, simplify it. Simplify this expression into one of these. So in order to do that, we need to know the cosine of a difference formula. Alright, so I'm going to refresh your memory. Hopefully you've read through section 9.2 in your OpenStax Algebra and Trigonometry book, or you've looked at more instruction here, and you've seen these cosine of a sum, cosine of a difference formulas. So I've got them written down here. These are the sum and difference formulas for cosine. And I've gone over in other objectives, the sum and difference formulas for sine and for tangent. So the sum and difference formulas for cosines. Now for the sum of two angles, when you're taking the cosine of, say, angle alpha plus angle beta, you add the angles up, get a new angle. The cosine of this new angle, the sum, you can rewrite it as an expression involving the cosine of each individual angle. So the cosine of alpha plus beta is equivalent to the cosine of alpha times the cosine of beta. So it's the product of the cosines of the separate angles. Alright, then here's the tricky part that people tend to forget. Then it's a minus over here. The cosine of a sum of two angles ends up being a subtraction, ends up being a difference. Minus, and then the product of the sines of the angles. The sine of alpha times the sine of beta. And then it's very similar. The only thing that changed are these signs here. The pluses become minuses, minuses become pluses. For the cosine of a difference, right? The cosine of a difference of two angles, the cosine of alpha minus beta, is equal to the cosine of alpha times the cosine of beta plus, right? If there's a minus in here inside this cosine, if you're taking the cosine of a difference, it ends up being a sum. All right. So again, that's something that people tend to forget. So the cosine of alpha minus beta is cosine alpha, cosine beta, plus sine alpha, sine beta, the sine of alpha times the sine of beta. So both of these, though, you have the first term is the product of the cosines of the angles. The second term is the product of the sines of the angles, right? The only difference is what you're doing in the middle, right? Cosine of a sum of two angles is a difference. The cosine of a difference of two angles is a sum. All right, and again, I've gone over the sum and difference formulas for sine and the sum and difference formulas for tangent in videos on other objectives. So we're going to be using one of these, right, in our expression here. In fact, in that question, they asked us to simplify the following expression. It was the cosine of alpha minus beta, the cosine of a difference of two angles in the numerator, divided by, and then the denominator was the sine of alpha times the sine of beta. All right. Now, I just showed you how to rewrite an equivalent expression to the cosine of a difference of two angles. So remember, the cosine of alpha minus beta is the cosine of alpha times the cosine of beta, and then plus. The cosine of a difference is a sum. Then plus the sine of alpha times the sine of beta. Alright, so that's what I'm replacing all the numerator with. Right? So that's the whole numerator. Divided by this sine of alpha times sine of beta. Now I hope you recall that if the numerator has multiple terms, you can divide each of those terms by the denominator. Right? So that fraction is equivalent to the first term. Take cosine alpha times cosine beta and divide that term by the denominator, right, divided by sine alpha sine beta, and then plus, and then this second term divided by the denominator, sine alpha sine beta divided by sine alpha sine beta. All right, sine alpha, that's an alpha, sorry, sine beta. All right, and then we'll do some rewriting and simplifying here. All right, now one thing I'm noticing, this first term, you have a factor of cosine alpha in the numerator and a factor of sine alpha in the denominator. Remember how that can be rewritten. Right? The cosine of alpha divided by the sine of alpha, or over the sine of alpha, that's the cotangent of alpha. Remember, one of those quotient identities. Same thing for the next part of this product, right? This is this times cosine beta over sine beta. Well, cosine beta over sine beta can be rewritten as cotangent beta, right? One of those quotient identities. Plus, and then you may notice that I have a factor of sine alpha in the numerator, sine alpha in the denominator. So those become, 1. And then sine beta in the numerator factor, and a factor of sine beta. So this is just 1, right? This is anything divided by itself ends up being 1. And this is as simple as this can get. Right. And this is actually one of our options when we look back. So this cosine of alpha minus beta divided by the sine of alpha times the sine of beta is equivalent to the cotangent of alpha times the cotangent of beta plus 1. Again, as long as alpha and beta are angles that make all these things defined. Right. So I'm back here. Which of these options is that? That's this one right here. Wonderful. And they go through the same procedure I just went through. They multiply the numerator and denominator by the reciprocal of sine alpha sine beta. All I did was divide each term by sine alpha sine beta. It's the same thing. Alright, so again, depending on what sum shows up, is it the cosine of a sum, the cosine of a difference, or the sine of a sum, the sine of a difference, or the tangent of a sum, the tangent of a difference, depending on which one of those shows up, you're going to be using different formulas. So hopefully you know all your sum and difference formulas for sine, cosine, and tangent to be able to do something like this, right? To be able to simplify a trigonometric expression like this. All right, so hopefully watching me do this one will help you when you're going about doing these problems on your own, and I'll throw up another video on a problem like this as well after this, a video number 2 on this objective. So hopefully these help, and thank you very much for watching.